Welcome to the CE 373 Soil Mechanics Lab in rooms S224 and S228. The Soil Mechanics Lab is used in support of the CE 372 Soil Mechanics lecture course. The CE 372 and CE 373 are required for civil engineering majors under all concentrations. The total space dedicated to this laboratory is 960 square feet with a maximum of 15 students and one graduate teaching assistant. Students access the lab at the door entrance in room S224. There are lab safety information and safety signs attached to the door that inform students that eating and drinking are not allowed. At the entrance of the lab, there are general information about campus and lab emergency procedures. There are 2 emergency exits and 1 exit in the room S224, and the second one is in room S228. The lab also has signs about safety equipment, including a first aid kit, eye wash station, and fire extinguisher. The fire extinguisher is located outside just next to the entrance door, and it is due for inspection in May 2022. The Office of Environmental Health and Safety certifies the safety equipment on a regular basis. Students are required to use personal protective equipment, including safety glasses while operating the loading machine or mixers on soil samples. Also, heat resistance gloves for handling hot objects and soil samples out of the drying oven. Also, they are required to use dust masks while handling the fine soils. These equipments are provided to the students during the labs. The CE 373 lab outcomes are for students to apply the basic principles and all concepts of soil mechanics and utilize test equipment to determine soil properties and behaviors. Also to design and conduct standard experiments, tests commonly practiced by geotechnical engineers. Also analyze the experimental data to support judgments or reach conclusions on soil properties, and act in team environment to perform soil tests and analysis. ABIT student outcomes met by this lab include outcomes 5 and 6. The professor or the graduate teaching assistant presents lab concepts and information here using the whiteboard. The students assemble here around the table. The major lab experiments conducted by students in the lab include specific gravity test. In this test, students apply a vacuum on a soil sample in a flask with water by using a vacuum pump to determine the specific gravity of the solid particles of a soil mass. Another test conducted by the students in the lab is sieve analysis test. In this test, students run an oven dry soil sample through a set of sieves on a mechanical shaker to determine the grain size distribution of a soil mass. Also, students conduct the hydrometer test. In this test, students use hydrometer in a soil-water mixture in 1 liter graduated cylinder to determine the grain size distribution of a fine soil mass of silt and clay by monitoring the hydrometer readings in the mixture with time. Also, students conduct attribute limit test. In this test, students use the liquid limit device cup and glass plates for a clay soil sample to determine the liquid and plastic limits of tested cohesive clayey soil. Also, students conduct compaction test. In this test, students use sliding hammer to compact clayey soil in a steel mold under different water contents to determine the maximum dry density and optimum moisture content of the soil after compaction. Also, students conduct consolidation tests. In this test, students apply different loads on a cylindrical clay specimen using the consolidation equipment, and then they monitor the deformation of the specimen with time during the loads application to determine the pre-consolidation pressure and compression and swell indices of the soil that are used in estimating the soil settlement due to loads of any prospective structure. Another experiment conducted by the students in the lab is the direct shear test. In this test, students apply an increasing shear stress on a soil sample under a constant normal stress using the direct shear box equipment. During the test, students monitor the shear stress applied on the soil and the horizontal and vertical displacements of the soil using different gauges. The students analyze the data collected from the experiment to determine the shear strength parameters of the soil, including the soil's cohesion and internal friction angle. In this lab, students conduct an unconfined compression test. In this test, students apply a gradually increasing load on a cohesive clayey soil specimen using the loading machine and records deformation during the load application to determine the unconfined compression strength of the soil. In the CE Laboratories folder in the Google Drive, there is a summary page that describes the features of the space for your reference.